Good morning, folks. First of all, I would like to welcome everybody here to North Carolina. Maybe it is the right time for me to be here because I will be the only one, the last one to talk before the field trip. And by the way, after this visit, probably you may consider this area for retirement. Okay. I would like to, before getting started, just let you know, North Carolina, especially our water quality issues, kind of more isolated from, we're not mostly in the Mississippi River Basin, we're not in the Chesapeake Bay watershed, but we're suffering from the same problems. We have so many smaller size river basins, like the Neuse River Basin and the Pamlico River Basin, and we start from west to east of the state, very pristine mountains area where people who would like to hike and camp go to this area during the spring and fall to enjoy the scenery and the weather. And then move from in the middle of the central part of the state where we have the larger concentration of our population in Charlotte area and the Triangle area where we are here right now in the Triad. And then we move down to the East Coast. We have the Central Plain and then the Lower Coastal Plain, where the Central Plain we have the concentrated pork industry, and we are second to Iowa in pig production, swine production, and so all of this waste has to be taken care of. Then we have the row crops that are happening in the Lower Coastal Plain, or poorly drained soils, lots of nitrogen, and very close to nutrient-sensitive water bodies. So this is why we're going to be traveling about 2 hours to where the actions are happening to see the research sites that are related to drainage. Before just giving you some of what we're currently doing, I would like to acknowledge the team that we are working with, Dr. Xian Tian and Lamia, Negm, Chad Poole, Yulu, and the other PhD students that presented their posters yesterday. I would, since most of our students presented their data yesterday, I'm just going to give you kind of a very quick overview of where we are and focus on the couple sites that we are going to visit this afternoon. So the water table management site, this is in Pool Farm, and this site has been instrumented through an earlier NIFA AFRI foundational grant in 2012, and we continued the site with this CAP project, or Water Challenge project. And we do have the free drainage and then the controlled drainage, and then what we call it the smart controlled drainage and irrigation system. And in North Carolina, we have a challenge when we have dry conditions. We don't have precipitation. In July, it will be very different if a field in Minnesota does not have precipitation in July. So maybe kind of a no rain for a week or two could cause the farmers a lot of yield losses. And at the same time, if you would like to irrigate, then you irrigate, and then after 3 or 4 days, you're going to have probably 2 to 3 inches of rain. So we said, okay, even if the farmers would like to consider irrigation, it is going to be a challenge to say, okay, when I'm going to irrigate and when I'm going to drain to optimize this system. So this was the motivation for this research. And basically, as a concept, this system has a sensor that senses the water level in the field, and if the water table go down below or up a certain level, then the irrigation or the drainage is triggered right away. So we define an optimum water table a priori based on the long-term data for the site, and try to maintain the water table with this optimum range. Okay, and this is what we are going to see in the field. I'm not going to go into details, so I will let Ehsan kind of present this in the field. And also the other site we're gonna visit is the drainage water recycling site. This is a kind of an elongated large ditch, has a kind of an area of about over 1 acre, and on both sides, one is not going to be irrigated, the other side is going to be irrigated, and we are trying to make kind of a complete water balance and nutrient balance on the pond itself. And I think this will be also an exciting site once we are able to collect data. And we are making plans to have data from these both sites this year. Then switching back to our modeling work as part of our project contribution into the transforming drainage work, we're talking about after finishing the testing and the calibration and validation of our DRAINMOD-DSAT model throughout the Midwest, through the data sites of the data sets that we have. We would like to basically apply the model at the large scale, at the regional scale. So we would like to answer a question that basically if controlled drainage is applied on each acre of land that is suitable to controlled drainage, what would be the effect of this application on the crop yield, on the water quantity, and on the water quality as well. This type of application is not going to take into consideration the in-stream processes. It's kind of an edge of field reduction for that. Also, we are going to extend our modeling to looking into the next 30 years for kind of the climate change scenario. We don't want to go beyond the 30 years because we said probably 30 years is a good lifetime for the drainage system. So if we are designing these drainage systems according to certain specifications, okay, then based on the next 30-year climatic regime, are we over-draining or under-draining? So is the optimum is shifting one way or the other? The other modeling exercise that we are involved in is modeling saturated buffers through a link between DRAINMOD and REMM, the Riparian Ecosystem Management Model. We are going to link these two models through a kind of a water balance component to the distribution structure. And the motivation here is to be able to also optimize the design process, so we are able to predict the water that's coming out from the field and what would be the length of the distribution pipe that would maximize the water that will pass through this pipe and minimize the bypass flow. Not the last one, but also another important exercise for us is to model the the drainage water recycling system. We have, I mean, the tools are being developed for kind of large scale application. But if you are going to design, if you are going to implement a drainage water recycling, and you're gonna have a system from scratch. We saw large dollar figures that are gonna be invested in that. So you really need to get a kind of relatively accurate predictions for that would be kind of a site-specific predictions. So we think that a model like DrainMod can accurately predict the inflows, the rates of the inflows into this pond, and also simulate the effect of the subsurface irrigation into these systems. And also an add-on, when we have the phosphorus component for the model, we will be able to estimate the water quality benefits of these ponds, because these ponds act like the detention ponds in the urban settings. So sediments will settle, and also the phosphorus will settle with it, and with the overflow will be clean without the particulate phosphorus mostly. The other thing that we are working on that is near completion is the development and testing of DRAINMOD-P, which is the version of DRAINMOD that simulates the phosphorus dynamics. And in order for us to be able to do that, we introduced several enhancements to the model. So this version will be dealing with macro pore flow. It also for the runoff that is generated by DRAINMOD, the original version, there will be an associated estimation of the soil erosion and sediment transport. And then we will be incorporating, or it is currently underway, incorporating a simple phosphorus cycle that deals with the different components of phosphorus and the inputs and outputs, and we will be predicting the surface and subsurface losses of phosphorus in both the particulate and the dissolved forms. I guess this is it for the presentation. I think I'm on time, right? Okay, great. Thank you.